So we're in the little tiny packet I gave you that says extra practice 5.1. Yep, so we're going to page 2. We're going to the second page of the packet where it says practice quiz number 2. And we are going to simplify. And remember, if you don't want to use theta, you don't have to. Don't let that confuse you. Just put X's if you want. So we're going to simplify these two problems. Now, kids, this is exactly what your quiz is going to look like. It's going to have 2 problems on a piece of paper just like this, and one of them is going to be one of these wheels, and one of them is going to be one like this. Now, who remembers what my strategy is with something that looks like this? What? What do I think about?
You do plus and minus.
I think about those identities. And those identities are 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. And sine squared plus cosine squared equals 1. Those are the Pythagorean identities. That's where I start when I have one of these problems. Because I'm hoping that I can pluck something out of that list and substitute it in. Can I?
Yeah.
1 plus tangent squared right there is secant squared. So I have secant over secant squared.
1 over secant.
Now I can cancel, right? So I'll cancel out one of the secants. What does that leave me with on top? 1 over the other secant.
Which is cosine.
And what's 1 over secant?
Cosine.
Cosine. There we go. So there you are simplified all the way down. Okay, so it's that easy. I know they're a little confusing, but I'm trying to prescribe it for you so you know exactly what to do. When you have a problem that looks like this, it's not that one. That one is that long string. When it's the other problem, not the long string, I want you to look at those identities. Now, I'm not writing those down for you. You know those. Those are memorized. Look at that list, and I promise somewhere in that list is going to be something that you're going to be able to plug into this problem. Okay? Now, we have done them where sometimes we have to rearrange things here, move things around. Not this time. This time we just straight substituted in. Okay? All right, let's take a second and get this one started. See what you can do with this one. Remember, if it's a cosine or a sine, don't change it. If it's a cosine or a sine, don't change it. We just put them over 1, right? But we change all the other things, and then hopefully what will happen?
Cancel.
We'll get some canceling, hopefully. So cosines don't get changed. Sines don't get changed. Secant is 1 over cosine. And tangent is sine over cosine. Now, does everybody understand why we are using sine over cosine and not 1 over cotangent? 1 over cotangent wouldn't help me cancel, right? So I'm using sine over cosine, and hopefully something will cancel. All the cosines. There's 2 on the top and 2 on the bottom, right? All the cosines. That's it. So what am I left with? Sine squared. There's 2 sines on the top, sine squared. Now a few days ago, a couple days ago, 5 days ago, I don't know, that seemed impossible. That's not so bad, is it? Let's try the last one. Practice test number 3. Or quiz. Practice quiz number 3. Notice we got the same sort of thing going on. So let's give them a shot. See what you can do. Go ahead and change the thetas to x's if you want. Well, it's 1 over cosine squared.
Oh, really?
Now, hopefully, as you're rewriting, stuff's canceling. I don't know. What'd you do with sine squared? Kept it. We keep our sines and cosines in these kinds of problems. We're changing into fractions. We keep our sines and cosines. What'd you do to secant squared? 1 over cosine squared. What'd you do with cosecant? 1 over sine. And cosine over sine. Good. Now, with any luck, we're going to lose some things. I think we lose all the sines, don't we?
Take 1 cosine out.
And we can take out 1 of these cosines. So what's left on the top?
1 over
1. 1's on the top. What's on the bottom? Cosine. Which is secant. Very, very good.
And 1 over cosine would be okay, right?
Yeah.
Yes, I said before, this is better.
You said
I thought you said square because
All right, now, oh my gosh, Miss Ford got a little tricky on this one. This one looks a little bit different. Remember, I told you that on the other problem, not this one, on the other problem, I want you to look here. We got a little bit of a problem though, because when I'm looking here, I don't see any cubes, do you? So let's look up here for a minute and see. Before I go to here, I think there might be something I need to do first. Take a sign out. We're going to take a sign out. We have a GCF. And if I pull a sign out, that's going to leave me with 1 minus sine squared. That's good news, right? Because that I can find down here. So the first thing we have to do in this problem is pull out a sine. Now, this right here, I don't know. That's where I'm looking right now. And I'm going to come down and this would be the identity that goes with, right? So let's see. If I were to move this sign to this side, just subtract this over, it would say cosine squared equals 1 minus sine squared.
Yeah.
Remember, sometimes we have to rearrange these to use them. So I'm going to rearrange it and write it like this. Now, that means I can take this and plug it in here. So now I have my sine, and then I have my cosine squared over cosine. Right? We substituted in cosine squared for 1 minus sine squared. And then what happens? Drop a cosine, so we're left with sine times cosine. That is not tangent. It would only be tangent if it were sine over cosine.
How do you, man?
It's just sine cosine. You get that, Armand? Good job. Okay, so on Monday, we'll have a quiz that looks just like this, okay? And if you remind me, we'll do a warm-up problem beforehand, okay? Okay?
Somebody put that on there.
All right.
We
It's
got
not even
that
close to lunchtime, it's 11:07.
Then we can just come back later.
Okay, now, no. No, we never go at 10.
We wanted 10 this week, earlier this week.
Well, I don't know. I must have been delirious or something.
We should
All
get.
right, get your notes out and your calculators. We need a calculator.
We should have second and third one. Only because it's Friday.
Get your notes out, please.
You are a big video.
I've watched 2 videos.
Okay. We are on the back of page 40. We are on problem B. On the back of page 40, we're on problem B that says solve the triangle. Now, do you all remember from our conversation last time that we use capital letters for the angles and we use little letters for the sides? So this would be side E. Look, this is side E, and this would be side F. So that's why over to the side it says find big D, little e, and little f. Those are the missing parts of the triangle.
D is 61.
So some of you have already figured out D is 61. Now I didn't check that arithmetic, is that right?
Yes.
Okay,
They all have
and we knew that had to be 61 because the angles of a triangle add up to 180. So if you know 2 of them, you're automatically going to know the third one, right? Now, who remembers this new thing we learned?
Law of sine.
Law of sines.
Sine big A over.
And the law of sines says, I'll take the sine of 61 and put it over 8. Now notice, it's not 61 over 8. It's sine 61 over 8. And that will equal the sine of 48 over E. So sine 61 over 8 equals sine 48 over E. The law of sines. And it's real easy to solve. Now I just cross multiply. So E sine 61 equals 8 sine 48. Now you're solving for E, so you're going to have to divide by sine 61. And then we're going to all type this in on our calculators, being particularly careful to close the parentheses. Alright, so 8 sine 48. You don't put those parentheses in, that comes in by itself. You have to close it. So 8 sine 48 divided by sine 61. For E, did you get, was this E? Yeah. Did you get 6.80 if we rounded the nearest hundred? On this test, I'm going to have you round everything to the 100. We're having too much issues with rounding, so everything's going to go to the 100. So everybody good with 6.80? Now, how am I going to find side F? Same thing. I'm going to start with sine 61 over 8. sine 61 over 8. And this time it's going to be equal to sine 71 over f. So Jordan Buford, what do I do next? Oh, Jalen Buford, what do I do next? Would you rather I call on Jordan Buford?
Call him Jordan Belfort.
Jalen, what do I do next? Come on, what did I do here? Cross multiply, that's exactly right. So f sine 61 equals 8 sine 71. Jalen, pay attention. Now we're solving for f, so we're going to have to divide by sine 61, right? And that'll give us f. So we can go to our calculator. 8 sine 71 close parentheses divided by sine 61. Did you get 8.65? And you have solved the triangle. All right, we're gonna do one more, okay? And then you can all scurry off to lunch. But we're gonna do one more. So let's look at the next one, problem C. Now, the only difference here, kids, is I didn't draw the picture. So you are gonna start by drawing your own picture. And it must be triangle A, B, C, because those are the letters I gave you. So I just drew triangle A, B, C. And when you draw your triangle, it doesn't matter where you put A, B, and C. Put them anywhere you want. Just make sure that if you put A here, angle A here, this has to be side A. So if you do your triangle and you had it set up like this, which is perfectly fine, your setup would look like this. See what I'm talking about? The arrangement doesn't matter as long as you have the right things lined up across from each other. Okay, what else do I know? B is 73. So this time we are finding angle C, side B, and side C. This is B, this is C. All right, let me stop there, make sure everybody's on board. So that's the setup. We gotta have that in front of us, because now we're going to start with our law of sines. After, we'll probably find this first. What's that one going to be this time?
65.
Everybody okay with 65? Remember, if you know two angles, the third one's easy. We just add them up and subtract from 180. Right? So now we're going to set up our law of sines, and we're going to use the 42 and the 6. So we're going to say sine 42 over 6. And then it doesn't matter. What do you want to say next? Equals what? Sine 73 over B. Remember, we have to do both of them. So the order we do them doesn't really matter. All right, so here we go. B sine 42 equals 6 sine 73. So B over here, 6 over here. B sine 42, 6 sine 73. Now I want B, so I'm going to divide by sine 42. I'm going to type that in on my calculator. So 6 sine 73 divided by sine 42. 8.58. What is that, B? 8.58. Are you okay with that? Okay, one more. Chase Stewart, can you set up my equation that's going to help me find side C? Can you set up my lost signs equation. It's gonna start just like this one. So it's gonna start with sine 65 over C, and what's that gonna equal? Sine 42 over 6. That's right, exactly. So we're starting with our sine 42 over 6 again, only this time we're saying sine 65 over C. So C sine 42 equals 6 sine 65. We're solving for C, so we're going to divide by sine 42. We're going to type it into our calculator appropriately. And did you get 8.13? Everybody okay with that? All right. I need you back at 53. You're going to lunch. I need you back at 53. Everybody's back at 53. What should be 36?
You were saying we should have left earlier. I'll return time.
Oh, you're such a goofball.